Okay, so we're going to talk about lines. Lines are very important because you use them in all grades of math, calculus, functions, and as you can see this year. So I want you to spend some time understanding the differences and what they're useful for. This one's pretty much the least important one except for noticing, and I know I'm kind of going to jump around on this, and anytime you know something already, just fast forward. When I divide this right side by this entire bracket, so I divide this on both sides, it disappears on the right side. So what I'm doing is I'm dividing both sides by this, right? And it's clear it disappears on the right side when I do that. And what am I left with? I'm left with the formula for the slope. So that's what that one is. So this is another thing you need to memorize, is the formula for slope. And you can always find the formula for slope. It usually says y2 and x2 here. But you can always find the formula for the slope and for any line if you're given 2 points. So keep that in mind. That's another skill I'm going to touch on at the end. You can always find the formula for the line if you're given 2 points. You can also find the formula for the line if you're given 1 point and m already. If they tell you the slope is, let's say, positive 2. You can find the formula of that line. I'm going to touch that at the end of the video. You can also find formulas for perpendicular lines if you're given the point of intersection and the slope of the other line. And we're going to touch on that at the end because that's the last course. And you're going to need both those skills. But we're going to move forward as if we don't need those skills. And we'll probably cover those skills as we go. But that's where that middle formula comes from. But the two most important formulas are this one. It's called the slope-intercept formula because in it you can see what the slope is. That's always going to be the value in front of x. And the b here is always going to be where this line crosses the x or the y-axis, called the y-intercept. The y-intercept is always when x is equal to 0. And you can see if we put 0 in for x here, 0 times m, we'll essentially get rid of this every time. And it will tell us where the y is always going to be b. And that's why it's called that. So it's probably the most useful version of it. However, you'll also see an example of this would be this. Y is equal to 3x plus 7. So right there I can tell you the slope is 3 and the y-intercept is 0, 7. And we can see that if we punch in 0 for x, 3 times 0, plus 7, and we follow bedmass order, 3 times 0 is 0, plus 7 is 7. And that's why you can essentially find the y-intercept every time using this. So right there from that formula, I can tell you the slope is 3 and the y-intercept is that. And that's very useful because now I can pretty much just find that spot. I know the slope is 3, so that means it goes up 3 y values and over 1 x value. So that I know my next point, if that y-intercept is 0, through 7, and I go up 3 y values and for every 1 x value, because this is essentially 3 over 1, I'm going to reach 1, 10. That means I have the other point right here, 1, 10, and then I can just draw a straight line through it like that. And boom, I've sketched my graph. And if I have an accurate graph paper, I can even visually figure out where y is, or where the x-intercept is, rather. The x-intercept occurs, and so I also want you to remember this. This is very important. Y-intercepts occur when x is equal to 0. So if you plug in 0 wherever you see x into the equation, you're going to find the y-intercept. And x-intercepts occur when y is equal to 0. You're going to find the x-intercept if you plug in y is equal to 0 in the equation. So given this equation, we found out that if we plug in 0 for x, I get 7. But what happens if I plug in 0 for y? Let's say it's plus 6 for convenience sakes, and we'll see why in a second. So how do I solve this? I subtract 6 on both sides. And I'm left with 3x is equal to minus 6. Divide by 3 on both sides, and x is minus 2. So that means the x-intercept for this particular line is that. And since I've changed the b, the y-intercept is now that. So that's my line. If I plot those 2 points on a graph, I can just draw a straight line through them. And I've successfully graphed my line. And I should probably label this and that. So that's how you would graph a line from a formula Very useful. You can also take any formula that you have and you can make what's called a t-chart. And y is always dependent on what x is. So you can always just start with x and throw in some simple values. Those are the three simplest values. And I can see when I put minus 1 in the above, I get 3 times minus 1, which is minus 3, plus 6, I get 3. And when I put in 0, of course, we already know I get 6. And when I put in 1 up above, I get 3 times 1 plus 6, 9. All of a sudden, I have 3 useful points on my graph that I could label and draw. Also notice that I instantly found out my y-intercept by making x equals 0. So very useful as well, skill to learn. That's I'd say the most important formula. This one is the next most important formula. It's often in this format. And I'll give you an example. 2x plus 3y. Actually, let's go with 4x plus 2y is equal to 8. All right? Yeah, it'll be something else other than that because you could divide each of those. So we'll go with 10. All right? You might also see this like this. And this is the same line formula. What did I do there? I subtracted 10 from both sides. I created a 0 on the right side and minus 10 on the left side. So you'll see it like that a lot. Occasionally you'll see it like this, but not often. And then if I wanted to turn this into the y slope intercept format, look, what is y being multiplied by? It's being multiplied by 2. So if I divide the left side by 2, I get y. And if I divide the right side by 2, what do I get? I get y is equal to minus 2x plus 5. Suddenly I've determined this formula is the slope intercept formula for the standard formula right there. So I have a handy way of converting it. So keep that in mind. Learn how to convert one to the other. And by the way, the standard formula, which I've made a mistake in some of my examples that I'm coming up, never has fractions in it. Never has fractions in it. So let's cover one other handy tool. Don't worry, I'll cover it in more detail. Suppose you have a slope intercept formula that looks like this. Just like that. And you can see that the slope is not a whole number, it's a fraction. And you'll want to say, okay, well, how do I convert that to a standard formula? Well, standard formula doesn't like fractions. So you'll need to see this denominator down here. I'm going to put both sides in brackets. So I'm going to make a copy. And I'm going to put the right side of the formula, the whole thing in a bracket. It's going to be a messy bracket, by the way. I'm going to put the right side in a bracket. And I'm going to multiply both sides by that denominator. So I'm going to multiply the left side by 3 and the right side by 3. Now over here on the left side, it obviously becomes 3y. And on the left side, when I multiply the first term, and by the way, you have to distribute it through, and this is a plus 3 because the denominator was plus 3. When I multiply times this first term, the 3's cancel out. So I get minus 2x. And when I multiply plus 3 times the plus 4 over here, I get plus 12. And there's a little shaky version. And now, assuming I want the standard form to look like the above, I got to get that 2x to the other side. So I'm going to add 2x to each side. And I'm done. I now have the standard form of this same line formula up here. Here's the standard form, and here's the slope-intercept form. They're the same line. If I put this into Desmos and that into Desmos, I will see the exact same line with the exact same slope. So it's important to know how to go back and forth, and I'll cover that more as we go. So that's the thing that you have to start with. You have to always keep these in mind. Let's go to our first example, our first assignment, which is, let's see, I think it's here. All right. And actually, this is a different version of it, so I'm just going to copy that to that and see if I have the other one. There we go. That's the one I actually gave you. And I'm going to make it a bit larger for you. Actually, I'm just going to zoom in. There we go. And we should keep a copy of our line formulas over here. So I'm just going to add a little extra space over here and keep a copy and zoom back in. There we go. Now let's look at this one. By the way, I've made a mistake over here. Three line. Oh, let me see if I've got it right here. Oh yeah, I've chosen 3 new lines here. And let's see, this is the first equation, I think. Yeah, these are all obviously in a slope-intercept format. Y is equal to something. So how do we solve this? Well, we're going to find out how they meet algebraically, and I'm going to let you, if you want to take a picture of this, go ahead. But I'm going to delete all the information down below. But I've got to keep in mind I want to find the X-intercept and the Y-intercepts as well. Here we go. How do I find out where they meet when they're in this format, the slope-intercept format? Well, if you'll notice these lines, lines only ever meet in one spot. The only times lines don't meet is in a parallel line. Parallel lines will never meet, and parallel lines would all have the same slope. So you would see y is equal to 2x plus 4. This line here and this line will never meet because they have the same slope and different intercepts. So they'll never meet. That's the only exception. Otherwise, lines always meet in one point, right? They always meet in one point. And you'll notice they share the same in x, y value at that point, which means at that one point, their y values will be the same. Their y values will be the same, which means their equations must also be the same at that one point. This is sort of a substitution method. So since their y values are the same at that point, in other words, the y of this formula, and if I want to put it on the other side like this, there we go. This might make more sense. There we go. Since this formula here is equal to y, and this y is equal to that y at that one point, and that y is equal to that formula as well, it's safe to say that at that one y value point, their formulas must be equal. So when it's in y-intercept form, it's very easy. You just make the values equal one another. And I'll show you a second method after I'm done this. Next, we've got to get all the x values. This is minus 1x, and this is 2x. We've got to get all the x values to this side and all the number values to that side. So if I look at it this way, this is 6 minus x, or minus x plus 6. It's all being added or subtracted. So I'm going to add one x to both sides. I'm going to add an x to both sides. And when you see x's that have the same exponent, power of 1, you can add them together. When they have the same, if they were both to the power of 2, you could add them together as well. But they must have the same exponent when they're being added. So I see 1x and 2x, and they add together for 3x. So what happens on this right side? Minus x plus x, they disappear. So I'm left with 3x. Oh, yeah, this is way too large then. Yeah, I'm left with 3x plus 3 is equal to 6. Now I got to get rid of this 3 on the right side, so on the left side. So I'm going to subtract 3 from both sides. And I'm with 3x is equal to 3. How do I get rid of something multiplying x? I have to divide it by the number that it's multiplying. So I'm going to divide both sides by 3. The left side disappears, and I'm left with x is equal to 1. Let me tell you another way that some students have trouble with algebra. So I'm going to go back to this one right here. Once I get the x's on the right side, I'm left with this. Once I get the x's on the right side, I'm left with this. Whenever you're trying to solve an algebra question, let's say you wanted to make it x is equal to something, you have to tell the story of x. In this case, there's only one story of x. X is being multiplied by 3, and you tell the story in bed mass order. And then you undo the story. How do I undo something being multiplied by 3? I divide both sides by 3. This is very important to remember because people will often just divide one side by 3. Whatever you do to a formula to keep it balanced, you have to add or do this, or divide by the same thing, both sides. It's, imagine a seesaw. If somebody gets on one end of the seesaw, to keep it balanced, the equal sized weight person must get on in the same position on the other side of the seesaw. So once I'm left with this, the undo story of this is divide both sides by 3. And we'll get into more complicated algebra. Anyway, I've come up with x is equal to 1. But the problem is, as I can see up here, I've got it right so far. But the problem is I don't know my y value. Well, you can take either formula, and I like to take the easiest formula that has no minuses in it. And whenever I see x, I can put in instead 1. So I'm left with y is equal to 2 times 1 plus 3. So that's 2 plus 3 is 5. Y is equal to 5. So suddenly I have my coordinates here. It's going to be 1, 5. I also want you to get into, and of course as we can see up here, that's true. I also want you to get into proper math notation. So when you have a formula like this, your next line I want you to line up with the equal sign. And I don't want you to go to the right or the left. I want you to always have that equal sign right under the last equal sign. This allows your teacher to clearly see the steps you took and give you full marks. It also allows you, notice even this last one's slightly out of whack, and it's still not quite balanced, but notice how these equal signs are right across, right above each other. This allows your teacher to see exactly what you've done. And same when the equal sign is just the y. So here's how you would solve for that last one when we wanted to figure out when x is 1. Your next line, you don't have to repeat the y. You can just do an equal sign. Now we're going to put 1 in for x. And you want to write each step as a mathematical thing happens, because not only will you spot your mistakes, but your teacher will be able to give you full rewards. So if I skip all this and your teacher wanted to see if I knew how to do bed mass, he's going to give me half marks. If I do all of that and I happen to make a mistake somewhere along the line, and I go, I don't think it's 6 because I can see it crosses at 5 up above, I can go back and look at my formula and say, oh, right there. That's not correct. That should be a 2. But if I haven't written that down, if I get so confident about my abilities, I'm not going to spot that error. So I want you to get in the proper math technique as well. Let's look at another way to do it. This is the alternative way. Notice that the y's here, both have a 1 in front of them technically. You don't see anything, and that's the invisible 1. There's always an invisible 1 multiplying the y up here. Well, I want you to pretend this is a great big subtraction table. And we're going to take everything up here and subtract every y down here. They're both positive, so I'm going to do that. What's positive y minus y? It's 0. And here's the tricky one next. What's 2x minus x minus 1x? Well, 2x minus 1x is 2x plus 1x, and it's 3x. So be careful about minus situations. One's the mathematical operation, and the other is the symbol of the item. So that means 2 minus 1x here is actually 3x. And we're going to discover the next thing up above. What is plus 3 minus plus 6? It's minus 3. Now all I have to do is solve. I'm sorry about that. There we go. And this is slightly out of whack. Now all I have to do is solve this algebraically. I have to tell the story of x in bed mass order. Let's tell the story of x. What's happening to x? 1. X is being multiplied by 3. So it's in bed mass order, and multiplication comes before subtraction. 2. 3 is being subtracted. Now I have to reverse that story, starting with number 2 first, and reverse all the operations. Add 3 to both sides. Divide both sides by 3. Now I have an official step for doing unraveling algebraically any algebra that I need to undo. So let's add 3 to both sides. When I add 3 to both sides, I get 3 on the left side, and I get 3x minus 3 plus 3, which gets rid of it. Then if I take the next step, 3 divided by 3 on the left side is 1, and 3x divided by 3 on the on the right side is 1. I get x is equal to 1 again. I've come up with the same x value with a different technique. It depends which one you like. I always like making the equations equal one another, but you'll discover when it's in the standard format, that won't work. The only thing about this method is when you subtract like this, make sure you're aware that it's a minus minus and a minus plus. This minus is separate from the symbols in front of these things. Well, that's great. Let's go on to the next ones, and we're going to practice the same thing. Oh, by the way, stop the video and see if you can do the next two without me. If you get the next one correct, move on to the next one. If you don't get this one correct, play the video. Here we go. So we're going to use the two methods. My favorite method, take the two equations and make them equal one another, because that's the only situation where their y's will be the same and their x's will be the same. Well, I got to get this 3x to the right side, so I'm going to add 3x to both sides. I'm going to give it a little bit of room there. And I get minus 3x over here, plus 3x, minus 8. It's obvious that this part here disappears. So I've got that right now. Now I'm going to add 3. Oh, what is 2x plus 3x? 5x. Now I'm going to add 3 to both sides to get rid of that minus 3 to get the numbers to the right side. So I got to add 3 to both sides. What happens on the left side? It's clear that disappears. And I got 5x is equal to minus 5. Okay. Now I have to divide by 5x. And by the way, you could tell the story at this point here, right there. You can tell the story of x to figure out what's going on, and I'll get back to that actually. And I'll even put it an extra step in here. I'll have 5x minus 3. How do we solve that? Okay, and now I have to divide. What's happening to x is being multiplied by 5, so I have to divide by 5 both sides. When I do that, I get that. Now, how do I solve it? I take any, for y, I've got my x value. I take my y value, and wherever I see x, I put in minus 1. So y is going to be 2 times minus 1 minus 3, which is equal to minus 2 minus 3. Oh, there we go. And therefore, y is equal to minus 5. So suddenly I have my coordinates. My coordinates are minus 1, minus 5. And I go up and see if I got it right. And sure enough, I did. Now I'm going to backtrack for those who aren't good at algebra. How do I solve this situation right here? Tell the story of x. We're trying to get x all alone as x equals to something. So in bed mass order, what is happening to x? Well, in bed mass order, it's being multiplied by 5. Nothing else in multiplication division, so we go on. It is being 3 is being subtracted from it. So now I have to tell the story in those reverse those number orders. So I start with number 2. I have to add 3 to both sides. And then I have to divide both sides by 5. And that will get x all alone and tell me what x is. Practice your algebra. The faster you get, the less you're going to have to use this method, because right away I can say, okay, in reverse bed mass order, I have to add 3 to both sides. And by the way, whenever you move a minus 3 to the other side, it becomes a plus. So the sign is the opposite. And then whenever I'm doing this, it actually, on the other side, it will become a division. So it's interesting to note that multiplications on the left side of an equation become a division on the right, or back and forth, and that subtractions on one side of an equation become an addition on the other side of the equation. Minus 8 plus 3, because this is technically in brackets, you've got to solve it. First, minus 8 plus 3 is minus 5. Minus 5 divided by 5, minus 1. So you can get faster and faster at your algebra, and the more you practice it, the faster you'll be. What about this other technique I mentioned? Well, we're going to subtract one line from the other, and I'm going to go a little bit faster here. What's y minus y? 0. We're getting rid of the y's. What's 2x minus 3x? Well, it's 2x plus 3x. It's 5x. So practice your negative positives If you're not good at negatives positives, the more you practice, the more good you'll get. Minus 3 minus minus 8 is minus 3 plus 8, which is plus 5. And then if I use my algebra skills here, I can say, what's the story of x? It's being multiplied by 5, and then 5 is being added to it. So I'm going to have to reverse that story. I'm going to subtract 5 from both sides, and then divide both sides by 5. And I get that. Once again, how do I find my y value? I take any of these formulas, and wherever I see x, I put in the x value I just discovered. Minus 3 times minus 1, minus 8, and I get plus 8, or sorry, plus 3 minus 8, which is minus 5. And once again, that method works as well. There's another method, and technically when I make the equations equal each other, it's called substitution, and I'm making this y, I'm replacing this y over here with the formula. I'll show you in a more complicated standard format, but most people don't like substitution. You will need substitution as you go. So again, pause the video and see if you can do this one on your own. Okay. You can always freeze frame something, by the way. Press print screen. Open up a version of Paint that you have. So I'm going to make a new version of Paint here. Print it. And then whatever line you're working on, you can expand it, crop, and now you can work on it on your own. So you can always grab a sample from the screen to work on something. Well, let's work on it. Let's try a substitution. So we're going to make this equation equal this equation and see if we can come up with this 5 right here. Okay, I've got to get all my x's to one side. So I'm going to add 3x to both sides. And I'm left with 2x plus 3x. It's 5x minus 1. Now I want to get rid of that 1. So I'm going to add 1 to both sides. On the left side, those 3x's have disappeared. I'm going to add 1. And I've got now 5x. And by the way, I'm just going to pull this back to keep my equal sign balanced. I've got 5x is equal to 25. I divide both sides by 5, and I see that x is 5, and sure enough, it's 5 on the graph. How do I find my y value? I take my simplest equation, obviously that one's very simple, and wherever I see x now, to find my y, I'm going to put in the x value I discovered. So I should see 5, 9 as my intercept, and sure enough, I do. All right, let's go back and see if the other method works. And that's where I subtract the top method line from the bottom line because both their y's are equal, are the same thing, plus y. What's y minus y? It's 0. What's 2x minus minus 3x? It's 5x. What's minus 1 minus 24? It's minus 25. Let's use our algebra. We're going to get the 25 to the other side of the formula. And I added 25 to both sides. Then I divided both sides by 5. And sure enough, I get my x value again. And then the y technique is the same thing. You just plug y in. So we're going to use the other formula to show that it doesn't matter which formula you use to plug in the x value, because they both meet at this one spot. Now, if you don't get the same value, then you know you might have made a mistake somewhere along the line. So you get minus 15 plus 24, which is 9, right? Sure enough, that's where they meet. Now, let's go back to our 3 formulas, the way they are. My other question is, where's the y-intercept? In other words, y-intercepts exist when x is equal to 0. When x is equal to 0. Well, I can just plug in. I can know automatically that that's the y-intercept from the y-intercept information. That's why this formula is useful for that. But just to make sure, when I do 2 times 0 here, it becomes 0. When I do minus 1 times 0 here, it becomes 0. 0 plus 3 is indeed 3. And 0 plus 6 is indeed 6. So you can see why that automatically gives us the y-intercept, which means 0, 3 and 0, 6 are the y-intercepts for these two lines. If I look carefully on the graph, sure enough, that's true. But what about the x-intercept? Now I can see it here and I can see it here, but how do I find it algebraically? Well, x-intercept will require a bit of algebra, and x-intercepts happen when y is 0. So we're going to do these one at a time. We're going to start with this one, and we're going to make y 0. It's going to take a bit of algebra. What's the story of x? It's being multiplied by 2, and 3 is being added to it. What's the reverse story? Subtract 3 from both sides. So I'll try to, I don't know if I'll be able to, I'll keep the things balanced here. What do I have on the left? 0 minus 3 is minus 3. And I'm left with that. Oh yeah, it's not going to be quite even. I can see that. Now I have to divide both sides by 2, because x is being multiplied by 2. So I get minus 3 over 2 is equal to x. So that's an interesting thing. If I put it in decimal format, which decimals will show me, it's minus 1.5 comma 0 is indeed the intercept of this line. Sometimes your teacher will want things kept in fractions. Sometimes she'll want it in decimals. It all depends. But if you look, that's true. That's minus 1.5 comma 0. I'll let you pause the video and try to do it for this one. What you do is you make the y's equal to 0. So at any time, pause the video and see if you can finish it the same way. So I'm going to make y's equal to 0. And I have to solve for x. Now what's happening to x in bedmass order? It's being multiplied by minus 1, and 6 is being added to it. So I have to reverse that. I have to subtract 6 from both sides. What's happening to x? It has minus 1 multiplying it. So I have to divide both sides by minus 1, which means my x-intercept for this line is 6 comma 0. It's very important to learn this. And sure enough, there it is. Now if we go through all these and pause the video and see if you can find, and you might say, well, no, I get it. But the more you practice on a test, the less test anxiety you'll have. So make sure you practice. Now I don't need to do the y-intercepts for you because it's quite clear. There's the y-intercepts. 0 comma minus 3 and 0 comma minus 8. And if I look at the graph, sure enough, 0 comma minus 8, 0 comma minus 3. So that's the nice thing about y-intercept, slope-intercept formula. As you can see, the y-intercept right there. But to find the x-intercept, I have to make the y 0, and then I have to tell the story of x. Now, I'm not going to keep telling the story of x. You should get good at it and see what I did there. I added 3 to both sides. So that means, again, for this one, oh, did I use the right one? Yeah, I did. So for this one, again, it's 1.5. Is it positive or negative? It's positive, comma 0. And when I look up the 2x minus 3, 1, which is in red, sure enough, there it is, 1.5 comma 0. What about this other one? Well, this other one, I make y is equal to 0 because that's when it hits the x-axis, when y is 0. Learn and understand that because it's going to come up over and over again. In reverse bedmass order, I have to add 8 to both sides. No, let me just get rid of that. Sorry. Add 8 to both sides, and I'm left with this. And then I have to divide both sides by minus 3. And I get x is equal to 8 over minus 3, which you never leave the negative down in the denominator. So it's minus 8 over 3. And it's kind of weird, and we kind of can't see it in this one. If I zoom in, I can sort of see that I'm close to that. You can see it's not quite in the center. It's kind of more over there because the center's right there of the square. And if we had it in Desmos, you could see it more clearly. I would like you to open Desmos to see it. And if I put that in number form, 3 goes into minus 8 twice and leaves 2 left over. So it's, I gotta close this. Hello. Okay, come on in or leave it in the lobby, whichever you want. So, And if you throw in the decimals, you'll see this value in decimal goes into 8 twice, so I get minus 2, and it leaves 2/3, which is 0.666. 2/3 is 66666 repeated. So that's what you'd see in decimals, and it'll round it up. You should learn your fractions too. 1/3 is equal to 0.33333333. 2/3 is equal to 0.6666666. 1/4 is equal, or 1/2 is equal to 0.5. 1/4 is equal to 0.25, and there's a few other fractions you should learn. When I have 5 up here, 4 can go into 5 once and leaves 1 left over, so that would be 1.25. So learn how to convert your fractions to whole numbers and your whole numbers to fractions. Let's move on to this. Obviously the y-intercepts are right there. 0, minus 1. There it is there. And we can't see it on this one. 0, or 0, plus 24. I should have included it. It's way up there. But let's see what our x-intercepts are. Well, that's when y is equal to 0. So I'm going to just make it equal to 0. I got to add 1 to both sides. I got to divide by 2. Which means at 0.5, 0 is when this line will hit the x-axis. And sure enough, if we look closely, and even though the squares aren't drawn properly because there is a line there, it goes right through at 0.5. And just looking at my graph on this one, I should get an 8, 0 out of this one. So let's see. We're going to make y 0, because that's what y is at the x-axis. Decimals is a much faster tool for figuring this out. I've got to subtract 24 from both sides. I've got to divide by -8. Minus 24 divided by -3. Sorry, I got to divide by -3. Minus 24 divided by -3 is plus 8. So that's my x value. That means the x-intercept is 8, 0. And like I said, we could see that from the graph. So these are skills you're going to have to need. You're going to have to be able to spot the slope. You're going to have to be able to spot the y-intercept, and you're going to have to be able to figure out the x-intercept. You may stop and practice the stuff, but I'm going to go on to the other 2 assignments. So again, that's an important thing to memorize. The second assignment, I've made it purposely tough, and the mistake I've made here is you will actually never see a standard format with a fraction. This should actually be multiplied by 3 on both sides, and the actual standard format of this, my apologies, should have been 6y is equal to 4x minus 42. That's the actual standard formula for that one, so you might want to write that down. How did I do that? I multiplied both sides by the denominator of 3, so practice that. And over here, stupidly again, you would never see a fraction in a standard format, so I'm going to multiply both sides by 2. The left side is 12y. The fraction disappears, and the 3 becomes a 6. So I essentially multiplied every term by 2. And this is the actual standard format. So my apologies. You would never, ever be presented with a fractionary standard form. So I should actually just work from that basis. You will never see it presented. But it's a good example of how to convert a fraction. So I'll just leave it there for conversion points. But what are we asking here? We're going to ask the same things. We're going to try to solve everything. Now, I gave you step-by-step instructions. And I'm going to go through 3 ways. There's 3 ways to do this. But I'm also going to use the standard format, because you're never going to be able to be presented with a fractionary format. But we are going to learn how to convert this to a slope-intercept format, so we might as well practice. So again, I'm going to try to do this one, and then you're going to pause and study it. So the secret here is I'm going to make my y's or my x's match. But I think it's going to be easier to make my y's match, because I can see up here this is plus 4y and this is plus 2y. So if I just multiply everything here by 2, it'll be a 4y. So that's my first step. I'm going to try to make this 2y become 4y. How do I do that? I multiply each thing by 2. What's 2y times 2? It's 4y. What's 3x times 2? It's 6x. What's 12 times 2? 24. If you put these both into decimals, you'll see the exact same line. So I'm also going to show you, in case you're not strong on your expansion, what happens there. So when you're multiplying both sides of an equation by something, you should keep one, if one's longer than one term, you should keep it in brackets. This one I don't have to. I can just say times 2. Okay, and in expansion, you distribute plus 2 times this and plus 2 times plus 3x. This applies to the 3x. So plus 2 times 2y is 4y. And plus 2 times plus 3x is plus 6x. It's very important to keep track of the symbols. And on the right side, of course, is 24. Now, look, did I get the same thing as the left? Yes, I did. Practice your expansions. Very important tool. So now they match. Now I'm going to enlarge this a bit. I'm going to enlarge this a bit. I'm going to try to put them one under one another. Now, you won't always have the x's on this side match. For instance, I'll show you an example where the 2x might be on this side, but they're often going to be like that. And I'm going to subtract them. And remember, this subtraction applies to each term in here. I'm going to subtract it. So what's 4y minus positive 4y? 0. That's why I did it. I want to get rid of the y. What is minus 2x minus plus 6x? Minus 2x minus plus 6x is minus 2x minus 6x. It's minus 8x. What is 8, positive 8, minus positive 24? Well, it's minus 16. So I'm left with this. 0 minus 8x minus 16, so it's really minus 8x is equal to minus 16. I think you can see I divide both sides by minus 8. When I do so, I'm left with this. Now all I have to do is take either of my original lines, whichever I feel is simplest. That's got a bigger number, so I'll try this one. And put x in for my value of x, wherever I see x. So I got 4y minus 2 times 2 is equal to 8. I got 4y minus 4 is equal to 8. What does algebra say? What's happening to y? I'm trying to get y all alone. It's being multiplied by 4, and 4 is being subtracted from it, so I'm going to do the reverse. I'm going to add 4 to both sides. It's always got to be both sides. I'm left with 4y is equal to 12. I'm going to divide both sides by 4. 4y divided by 4 is y, and 12 divided by 4 is 3, which means the point of intercept for these two lines should be 8, 3. So I'm going to go back. Whoa, look at that. I did so. You can see right away I did a mistake somewhere. And that's the problem is sometimes you can do this and you'll not see the mistake. Oh, I know what I did. It's obviously not 8, 3. The mistake I did is just in the end, I failed to realize. I looked at this number. It's 2. So I didn't even do that much of a mistake except transcribe it wrong. It's 2, 3 because here's the x value I found and here's the y value. And I'm sorry if I misspeak like that. Sometimes I do. So the values I found here's 2 for x and 3 for y, and sure enough when I go back up, that's what I have. Okay, a little bit more complicated like that, right? Is there another way I can do it? Yeah, there's 2 other ways. You can make both these equations into your standard slope intercept format, and it'll take quite a while, but you should still practice it. So let's see. I want to try to get y is equal to all alone because that's my slope intercept formula. Y is equal. I got 2x being added to my 4y, and then, sorry, in bedmass order, it's 4 is multiplying my y, and then I've got 2x being subtracted from it. Reversing that, I've got to add 2x to both sides. What happens on the left side? I I'm left with that. And by the way, you would rearrange this with the x first, even if the x has a minus sign, because that's what the slope-intercept format looks like. Now, what happens when I divide by 4 here? When I divide the left side by 4, it's this. But the right side, technically, you've got to treat it like this. The whole thing is being divided by 4. But there's an interesting thing about fractions that says that when I have two terms added, subtracted up above, yeah, I can write it like that. Or I can also write it like this. So they're both being divided by 4. I can break it up. That, after all, is all a fraction is. It's two things with a common denominator being added or subtracted, which means I can also break them up that way. Well, 2 divided by 4 is equal to half x, and 8 divided by 4 is equal to 2. So there, I have my slope intercept version. This is the exact same line as that. You should practice it because your teacher's going to want you to go back and forth between the two. And now, what do I have? I have the equivalent of a y expression for this. Now, this is called substitution. I could then make this also equal y equals something and make the two equations equal each other and then solve, as we did on the last page. Or I could say, well, I have a y is equal something here. Everywhere I see y here, I can just replace it with that equation. This is called substitution. It's longer, it's harder, but it's something that's worth learning. So instead of that y, I can replace it with the equivalent. Whenever you find something equivalent, you are allowed to replace it in an equation. That's how you solve a lot of unknown equations. So that 4 has to multiply that half x, it becomes 2x, and that 4 has to multiply that 2. Distribution, 8. And then it's plus 6x is equal to 24. Now I can see I have two common terms here. I got 6 apples and 2 apples. So it's 8 apples. Now it's just, again, algebra. I have to subtract 8 from both sides. X is equal to a half. Then I just take that half and put it into either of the original formulas up here to solve for my y, but you'll see that you get the same thing. I'm not doing that second step because we just did it, and there's no difference. So that's called substitution. In other words, I made y is equal, I changed this to a y is equal equation, and then wherever I saw y in the second one, I solved it. And the rule is when you're missing 2 values, but you have 2 equations, you can find those 2 values. Remember that. If you're missing 2 values, you need 2 equations. If you're missing 3 values, you need 3 equations. Otherwise, you can't solve it. If you're missing 1 value, you just need 1 equation. All right, and that's what algebra is. What's the other way? I'm going to keep this y is equal to, and I can put this as a y is equal to. Well, I can see that 4y is having 6x added to it, so I'm going to subtract 6x from both sides. And you might say, how do I know to subtract the 6x? Well, I'm trying to get y's all alone. So I've got to get rid of anything hassling that y. So on the left side, those 6x's disappear. And I want to rearrange this into intercept formula, which means the x comes first. When you're writing an equation, x values, unknown values always come first, and you write them in power order. But right now, let's just do this. If I divide both sides by 4, I get this, and I might as well show you how it's broken out down individually. I'm going to divide that by 4 and that by 4. So obviously this first one just becomes this, and this next one becomes this. Now I have the y-intercept formula for, the slope-intercept formula for this line is this. So the slope is clearly minus 3 over 2, which means it goes down 3 y units and over positive 2 x units as a slope. So it's going downwards, and the y-intercept is 12. And I can see, I might have gotten that wrong. Yeah, 24 divided by 4 is not 12. It is 6. Just goes to show you can screw things up quite easily. And there we can see the y-intercept is 6. So I now have 2 formulas that equal y, and I could just make them equal to each other. Pain in the butt, because on the left side here, I have a fraction, and on the right side, I have a fraction. I've got minus 3 over 2 on this left side. But we might as well learn another good technique. And on this left side, on this right side, I also have 1 over 2 as a fraction. 1 over 2. And I don't like fractions when I'm solving equations because adding and subtracting fractions is a pain in the butt. Well, I noticed that they're both 2. If they weren't both 2, if one was a 2 or a 3, I'd have to find a common number between them. Common number between 3 and 2 would be 6. But since they're both 2, all I have to do is multiply both sides, put both sides in brackets, and multiply. That's not a not equals, it's an equals. And multiply both sides by 2. The nice thing is the first term, all that you do is cross out the 2's. So I'm left with minus 3x. The second term is just multiplied by the 2. So I'm left with minus 3x plus 6. And on this other side, when I multiply by 2, like I said, all that happens is the first term is the 2's cancel out. That's why we're doing it. It's equal to x. And the other one, 2 times 2 is 4. And now look at that. I have no fractions. I can just solve it algebraically. I solve it by getting all my x's to one side and all my numbers to the other side. And I discover that this does indeed, oh, did I make a mistake here? I might have made a mistake here. Hang on. 3 half x minus 3x plus, yeah, look at that. Already, look at that. That's how you make an easy mistake. It's not 6. 2 times 6, 12. So that's got to be 12. And you can see when you go too quickly, and you can make mistakes quite easily. Like that. So if I subtract 12 from both sides, I get 4 minus 12. And that's minus 8. And then when I divide by 4, both minus 4 both sides, I get x is equal to 2. Then I substitute it in the equation to solve. But you can see this got pretty messy. It's a lot of fractions, and it's almost easy. It's much easier just to make these y's equal and subtract them. This was much easier than that. However, this is a useful skill because you will have to go back and forth between M-intercept and standard format. This part less so. I wouldn't use double substitution to solve it because now you're just going back to getting rid of the fractions. Why create the fractions and then get rid of them? Easier just to use this format to solve where they intercept, but if your teacher wants you to convert to intercept slope, learn how to do it. And she will. She'll want you to go back and forth. She just won't want you to do this method that I did down here. So the only other question is, what about my other questions? Where's the y-intercept and where's the x-intercept? Well, the y-intercepts are very easy to see in this format, but they're not easy to see in this format. They're not easily visible. The benefit of the y-slope-intercept formula is you can easily see y-intercept. However, the standard formula is actually very easy to figure out x-intercepts and y-intercepts. Let's start with the y-intercept. The y-intercept is wherever x is equal to 0. Well, wherever x is equal to 0, since x is multiplying something, that whole thing is going to become 0. That whole thing is going to become 0 every time. So we're essentially always going to be left with this when x is equal to 0. Well, that's easy enough. Up here, divide by 4, y is 2. So that means the y-intercept is at 2. Sure enough, there it is, 0, 2. Down here, dividing by 2 on both sides, and we've got y is equal to 6, which means the y-intercept for this line is at 0, 6, the blue line. Sure enough, there it is. Now, what about the other way? What about x-intercepts? You're going to find that the standard formula is much easier to find the x-intercepts because x-intercepts occur when what? When y is equal to 0. So say it over and over again. Y-intercepts occur when x is 0. Y-intercepts occur when x is equal to 0. Y-intercepts occur when x is equal to 0. X-intercepts occur when y is equal to 0. X-intercepts occur when y is equal to 0. X-intercepts occur when y is equal to 0. What are X or Y-intercepts? Where they cross the X or Y axis. X-intercept, intercepting or crossing the X-axis. Y-intercept, intercept or crossing the Y-axis. We can see the same rule applies when Y is equal to 0 in these equations. Anything multiplying 0 will just become 0. So the nice thing about these standard equations is those just disappear. Now I can see that dividing both sides by -2 here, x is equal to -4, which means the x-intercept for this formula is -4, 0. There it is. And over here, I can divide both sides by 3, and I can see the x-intercept is 4, 0. There it is right there. So the standard format, its use is finding the x and the y-intercepts. Very, very useful. Much easier than the slope-intercept. The benefit of the slope-intercept is really the y-intercept and the slope. The benefit of the standard is solving equations without fractions and finding x and y-intercepts easily. You will use the slope-intercept more, though, than the standard. So again, my mistake for including fractions, you should use this version here. And I'm going to send you this corrected version, actually, because it's not, you'll never see a standard, you're never going to see a standard formula with fractions, ever, 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 ever. It's this going to get tricky, though, because I put the standard formula in different structure. And again, for this one, you're never going to see a fraction in the standard formula, so I'm sorry about that. Let me just make sure I multiplied it right. I did. So I'm going to send you these. Okay. Let's pause and you see if you can do these next ones. And all you're going to be doing is lining them up and subtracting them. Now there's a little trick in this one because they don't line up properly. Right? There's the same terms are not on the left and the right side. And is that equals to 0? It should be equal to 12, right? Like that. Okay. So, what do I do? This should be equal to 12, I believe. There we go. What do I do? Well, you can line up everything on the left side of the equation. Find the terms that match. Okay, so I can just see, I'll just put the 2y under it. And the right side of the equation, I don't have any x values. I'll just put the 12. However, if you really want, you can either subtract 4x from this side, and it'll go over here, and then it'll balance up. Or you can subtract 3x from this side, and it'll go over here and line up with this. We'll see if you're more comfortable. Now, let's look at the y's. Oops. Yeah, let's look at the y's here. 2y and 6y, right? 2y and 6y. How do I turn a 2y into a 6y? I have to multiply both sides by 3. So that means every term gets multiplied by 3. So it's clear that this becomes 6y. What happens to 3x when I multiply it by 3? 9x. And what happens to 12 when I multiply it by 3? 36. Great. Now I have something that I can add or subtract. All right. What's 6y? I'm going to subtract the entire bottom from the top. What's 6y minus y? 0. There's nothing here. What's called 0? What's 0 minus plus 9x? Minus 9x. Equals. Here I got 4x with nothing underneath it. What's 4x minus nothing? 4x. And here I've got minus 42, minus 36. I got a big old number. It's minus 78. So there are all my numbers I'm working with. All I have to do is get all my x values on the same side. And that means I got to get this 4x to this side. Subtract 4x from both sides. So that means it's minus 9x. Minus 4x is equal to 4x minus 4x minus 78. What's 4x minus 4x? It's simply 0. What's minus 9x minus 4x? Minus 9 apples minus 4 apples is minus 13 apples. And I'm going to have to divide both sides by 13. 5, 6, yeah, 6. So 6 times 13 is 60 and 18, 78. So I get 8 is x is equal to 6. Boom. I've got my, oh, that was terrible. Let's see if I can get back there. There we go. There we go. Let's see, how do I find my y value? Well, you take the easiest formula. That's probably this one with the smallest numbers. And wherever I see x, I'm going to put 6 to get my y. You get 2y plus 3 times 6 is equal to 12. 2y plus 18 is equal to 12. Now, the story of y, I'm trying to get y all alone. I have to subtract 18 from both sides. I get 2y is equal to minus 6. Divide both sides by 2. I get y is equal to minus 3, which means my intercept is going to be 6. Sorry, these lines will cross at 6, comma, minus 3. Let's go see if that's true. Yep. There they go. So you can see this subtraction method for standard, even when there's gaps, works. Works quite well. What if I not comfortable with having nothing here? Well, let's subtract 4x from both sides on this top one. Subtract 4x from both sides. And what happens to 4x minus 4x on the right side? It disappears. And suddenly you have a nice balance of numbers over numbers and x's over x's. And you can do the normal subtraction. Just remember that when you're subtraction, if there's anything minus down here, a subtraction of each term, if there's a minus, it'll become minus minus a positive. So just keep in mind what subtraction does to each term. Get more comfortable through more practice. I'm not going to convert it and substitute it because it's quite clear this method is the faster. Now let's find the x-intercepts of both and the y-intercepts. The y-intercept occurs when x is 0, so we can just get rid of it. 6y is equal to minus 42. We're going to divide both sides by 6. And we get y is equal to 9. Oh, sorry, 6. My bad. What am I thinking? No, it's not 6. It's minus 9. It's minus 7. Sorry. I don't know what happened to my brain there. 42 divided by 6. Minus 42 divided by 6 is minus 7. And sure enough, there's my y-intercept. What about this one? Well, y-intercepts occur when x is 0. And I don't have a... There we go. That's what it should look like. It's all muddled because I was doing it. And so when x is 0, this disappears. When I divide both sides by 2, y is equal to 6. That's my y-intercept. Minus 7 for this one. 0, comma 6 for this one. Boom. Very, very handy. Boom. Now what about my x-intercepts? X-intercepts occur when y is 0. 6 times 0 is always going to be 0. So I get this up here. I have to do a bit of algebra. I have to add 42 to both sides. And I get 4x is equal to 42. Then I have to divide by 4. And I get x is equal to, geez, 10. It goes in 10 times and a half, 10.5. And if I go up here, right there, 10.5. So it's 10.5 comma 0. Down here, when y is 0, it just becomes 3x is equal to 12. And actually, the other thing I did that's unfair is this would never be presented to you like this. The 4x is going to always be on that side. So it's kind of unfair. And I'm going to send you the more corrected version. And then when I have 3x is equal to this, I divide both sides by 3. So x is equal to 4. So the x-intercept for this one is 4 comma 0. Right there. So you can see that works. And last one. Last one, pause the video, see if you can do it on your own. And I'm going to reformat this one up top to the correct version. This one actually should be 12y minus 1x, or minus x, is equal to 6. There you go. That's now standard format. Generally speaking as well, they would never make the x negative, so it's kind of tricky here. You'd multiply everything on the top by negative 1. And so in reality, you'd actually see this up top, because they never like a negative value in front of the x in standard format either. Oops, like that. So when I multiply everything by negative, that's what it becomes. So really, technically, this is the standard format. It's a weird rule, but don't worry. You don't have to worry about that rule. So these are the actual two lines. So I'm going to just stack them up, one on top of the other, and I'm going to notice the bottom one is a 4y. Now, notice the signs are different. I want their signs to match if I'm going to subtract them. By the way, if you want to add instead of subtracting, just make their signs opposite. Let's try that. Let's just try to get this number to 12, but keep it plus. Try to get this number to 12, but keep it a plus. So all I have to do is multiply it by plus 3. Let's multiply each term by plus 3. So 4y times 3 is 12y. 3x times 3 is 9x. And 12 times 3 is 36. Boom. Now, you might find this easier now that I think about it. Instead of subtracting, because these y's are opposite value. This is negative and this is positive. We're just going to add them. Minus 12 plus 12, 0. X plus 9, 10x plus 10x. Minus 6 plus 36, 30. So you might want that technique instead. Adding instead of subtracting, that means their signs have to be opposite. Some people would like it better that way, some people don't, but it's clear I'm left with 10x is equal to 30. I divide both sides by 10, and I get x is equal to 3, which means one of the x values where these lines intercept is 3. Notice I've made this one a little trickier because the y is not going to be that easy. However, all I have to do is take my easiest line formula, which is this one, and substitute wherever I see x with a 3. So I get 4y plus 3 times 3 is equal to 12. 4y plus 9 is equal to 12. Then I just have to use my algebra. Subtract 9 from both sides. Divide by 4. So y is equal to 0.75. So that means my intercept, where these two lines intercept, is here. And sure enough, when I look up, that's true. So you might find this addition method a little easier. So long as these y's cancel out, that's the point. When these y's cancel out, I can solve it. What about their x and y intercepts? Well, like I said, it's quite easy. You just make one equal to 0 and one not equal to 0. So y-intercept occurs when x is 0. So we just get rid of those x's. So I get up top, y-intercept, divide both sides by minus 12. We get y is equal to 0.5. So that's its y-intercept. When I go up here, there it is there, 0, 0.5. When I divide both sides by 4, I get y is equal to minus 3. So that's its y-intercept, 0, minus 3. And when I go up, oh, I did something wrong, I think. What did I do wrong there? Was it minus 4y? Oh, that's an equal sign. It's not a negative. Sorry, that's an equal sign. So it's plus 3, my bad. Divide both sides by 4, I get y is 3, 0, plus 3. And sure enough, there it is right there. What about their x-intercepts? What about their x-intercepts? Well, that's when the y values are 0. So that means these things would just disappear. And that's what I'm left with. So you can see the top one tells me right away. Minus 6, 0. That's way over here. We can't quite see it. Use Desmos. Put this line in and you'll see it. What about this one? Divide both sides by 3. X is equal to 4. 4, 0. There it is right there on the blue line. So you can see that the standard format makes it very easy to find the y-intercepts. Not so for the slope. For the slope, we'd have to rearrange it into the slope-intercept method. This is very, very useful. Now, one last thing. Long video, I know, but it's a useful video. At any time, just backtrack, fast forward, or whatever. Let's take two lines. And we're going to use our Desmos here. Okay. Tell me the slope of this line. It's quite obviously the plus 3. What about the slope of this line? Well, it looks like this one up here was 3 over 1, right? And that one down below is 1 over 3 with a negative sign. Those look perpendicular. You're going to discover perpendicular slopes are reciprocals, so flip of the fraction and change of the sign. Let's see if you can figure out what the reciprocal slope is, or the slope of a perpendicular line is going to be for 4x. Ignore the plus 6. The plus 6 doesn't have anything to do with it. Well, according to me, it's 1 over 4, and change the sign. Let's see if this is perpendicular. Sure looks perpendicular. Perpendicular lines form 90-degree angles with other lines. That's the definition of perpendicular. So we can see that two lines are perpendicular when their slopes are reciprocals and change of signs. And it doesn't matter if this is minus 1 over 3. Flip that, it's 3 over 1 and change the sign. So there's two perpendicular lines. So what's going to happen a lot is they're going to give you, let's see if I can make these a nice even spot they meet. I'm trying to find a good spot where they'll meet so that you can come up with, because I don't want to make it too mean here. And we're going to do plus 18 and see if we come up with a nice, there we go, look at that. So let's say they give you this spot and they don't tell you the formula of the red line. And they want you to figure out the formula of both lines. But let's say they tell you the formula of the blue line. Okay, let's say they tell you the formula of this blue line. And they want you to figure out the formula of the red line. Let's just keep that over here. Well, the first step you should say to yourself, well, I know the slope of the blue line is 3, and according to this guy, the slope of the red line is going to be the flip of that. So the red line is going to be the flip of that, 1 over 3, and change the sign. And change the sign. So that means that I know that the slope of the red line must be the flip of the blue line and a negative. So that's a start. Now I have the slope of the red line. Since I have a point here, I have two ways to solve this. I can either use this method, just pull out a bit, and actually, you know what? Just keep in mind that red line formula right there. We'll get rid of a lot of the junk here, and we're going to just crop. And yeah, there we go. And we're going to just make the font a little smaller. There we go. Yeah, the font's monstrous. Okay, so this is a handy formula to figure out when I have a point and a slope. What do? I just put the values of the point, the one point they gave us. How do I know to use that point? Because look, they both cross at that point. They both share that point. What was the y value of that point? 15. What was the slope I determined for the red line? That. What's the other x value of the point they share? 9. All right, so on the left, I just have y minus 15. And on the left, I got to distribute that minus third through. So I got minus third times x. And what's minus a third times minus 9? You can use your calculator if you want. It's this. But you should get handy at this. When I multiply this times minus 9, the minus minus makes them both positive. And 3 goes into 9 3 times. So this, positive 9, here we go. So when I multiply minus 1/3, it became minus because I'm subtracting it down there. So minus 9. The 3 goes into the 9 3 times, and the minus times the minus makes positive. So that becomes positive 3. You should practice your distribution. Now, notice I have a fraction problem. I'm going to multiply all terms by 3 to get rid of that fraction. have there. That's how you can get rid of any fraction. Multiply all terms by the denominator of that one single fraction. And if you have two fractions on either side, find a number that multiplies into both of them. I'll give you an example at the end of this. Now I just have to solve this algebraically and get y all on one side, right? So I have to add 45 to both sides because I'm trying to come up with the formula for this line. So I'm left with 3y is equal to minus x plus 54. And then when I divide both sides by 3, I have to divide every term by 3. And this divided by 3 goes in 18. And there I have the formula of the perpendicular line, and look at that. There it is there. So that means if I have a slope of the main line, I can figure out the slope of the perpendicular line and then use the point to solve it using this. This seems a little cumbersome. Is there another way to solve it? Yes, there is. But in this case, you'd have to solve for b and then redo it. So back to beginning, we know the blue line slope is this. They want us to solve the line for the red line. So I know the slope of the red line is going to be the flip and change of sign. So I know that's equal to m. Now I'm going to write my slope intercept. Y is equal to mx plus b. And where I see x and y, I'm going to put in the point I know. And I know the slope. And I know the x up above. I just got to solve for b now. So I get this. What's a minus? This is actually easier. What's a minus third times a 9? How do I get rid of that minus 3? I add 3 to both sides. And I get b is equal to 18. A little bit faster. So now I rewrite it, y, into the slope-intercept format with just x's and y's. And you can see that I got it. So a little bit faster solving for b. When it's fractions, when the slope's a fraction, you might want to use this method. A little bit faster. So I was able to figure out the y formula using that. What if they had only given me the slope? What if they'd only given me the slope of b? Could I still figure it out? Yes, you can. Because they give you a point. So if the slope of b was 3, and they told me it was 3, and that tells me that the slope of the red line, because they told me it's perpendicular, is minus a third, and I can still use those points. Same thing, we just did it, right? B ends up being 18, so now I know that the formula of that red line is this. What about the blue line? Okay, same thing. They gave me the points. So I can figure out the blue line using the same method. They gave me 1 point, and they gave me the slope. So I can just say 15 and solve for b. Therefore, the slope of the formula for this blue line is y is equal to 3x minus 12. Let's remember that. So I'm going to make a copy. That's the formula of the blue line. Sure enough, look at that. That's what it was. So long as they give you 1 point and the slope, you can figure out the formula of any line. And since perpendiculars are just the flip and the negative, you can figure out the formula of either line. So all you need is the formula, the slope. If they give you the formula, you'll be able to see or discover the slope by putting it into slope-intercept format and then working through the same logic, right? One last thing I want to cover. What happens if you're given a formula like this? And we'll put just x's in here, okay? I've got fractions everywhere. Well, if you multiply both sides, what number do these both have a factor for? Or you can just multiply them times each other, but sometimes it's better not to. 3 and 4 both go into 12. So if I multiply this left side by 12, 4 goes into 12 3 times. 3 times 1, 3x. 12 times 6 plus 72. This left side right side I also have to multiply by 12. What's 12 times 1/3 x? 3 goes into 12 4 times. I get 4x. And then what's 12 times 2? Plus 24. Boom. The fractions are gone, and this is the same formula. It just doesn't look like it. It's a good handy way to not deal with fractions for formulas. The only negative of this is you end up dealing with monstrous numbers. Anyway, that's a lot, but that's what you need to know for lines.